Okay, well, good morning, seventh graders. I hope you all are doing well as we begin a new week. And our last lesson that's new for this entire school year, page 510. I think it's a great place for us to stop as you go into eighth grade. We're talking about real numbers. Turn to page 510. You'll definitely want to look there. So we have what we call in the group of real numbers, which we have talked about this before. We have two groups. We have rational as are listed there in the book. And then we call irrational. Okay, so this should bring back some memory. Rational numbers are anything that's a ratio. 4 over 7, 4.5, 4, 37, -4, 3 over 13, right? Anything that is a rational number is a ratio. Okay, if you want to think about this, this is a ratio. Okay, so even a number like 2 over 3, which is equal to 0.6666 repeating, that's still rational, okay, because it's repeating. So that's okay. So we're good. So ratio, rational, repeating, check. Irrational are square roots of numbers that aren't perfect squares. So any square root, square root of 3, square root of 21, square root of 101, anything like that is going to be irrational. Then we have pi, right, because it never repeats. And then we have something like this, 0.12, 122, 1222. See, it's a certain pattern, right? So they can have a pattern, but because this pattern isn't the same, it's not the repeating as this one. See the difference here? This one's the same number repeating, or if it was like 0.18 repeating, right? It's the same number repeating. This one you can't ever repeat. You can't do it over the 1 or the 2. So that's why it's irrational. It has a pattern, but it does not repeat. Okay, not repeating. Cool. So there's some review. Now let me pull up a chart here. Let's see if I can do this. It's always fun to try and use my technologies here for my benefit, but let's see if we can do this. Add a picture of, this is from your book. So here we go. Yay. Oh, really? That's really disappointing. I think I can turn it. There we go. Okay, so this is from page 510 again. So real numbers, right? You see this box, I'm going to underline it in red, the whole box. So that's this little guy that has, I'm highlighting the corners of said box. That inside there are the real numbers. Okay, so out here in this space that's now in red, that's irrational. Okay, so like out here would be the square root of 3, pi, all those kind of ones. Okay, now rational, okay, you see that one, I'm underlining it here in green. That's going to be anything that is a ratio. So like that'd be 2 over 3. That would be anything that's going to be like a fraction. So 3 over 4, something like that. Integers then are any positive or negative number. So I'm going to put that in blue. Integers. So that'd be like -1, 0, 4, -2. Anything like that. Positive or negative, but they don't have a fraction that is repeating or anything. Now we get to whole numbers. I'm going to do that one in, go back to red. Whole include 0. That's the lowest whole number is 0. And then it goes 1, 2, 4, 1,000,000, 110, right? Any number greater than 0 and greater. And then back down here in black to our natural numbers. That does not start with 0. It starts with 1, 2, 3, and infinity, right? 4, 5, 6, 7, 100,000, 100,000,000, 10 bajillion, right? Anything that is a natural number that's not a fraction, okay? So that's how that chart works. We've talked about it before. So what I want you to do now is look on your book to page 511, okay? And we're going to do this example with that same picture. Make it a little bigger this time. Here we go. Okay, so look at example 1. Example 1. Whoa, come back here. Example 1. So it says place the square root of 13. So again, square root of 13 is going to be out here. Then it says place 3 over 5, that's going to be in the rational. It says place 0, that's going to be in the whole. Place natural, that's going to be 4. Place another rational here is -3 and 2 over 3. Okay, so if you're watching me, you'll know that's in the rational. And then integer here, we have -8, right? -14, right? So that's kind of how this will work. So your first homework problems, the first 8 of them are doing that. Okay, so the first 8 homework problems are just doing that right there. So not very hard. You guys got it. That's very straightforward. I believe in your abilities. Now, the second half of the homework here is just going to be learning how to use what's called the properties of math. Okay, you're just using the properties of math. So, for example, if they give you something that would look like this, right here, if they would say -4 plus 7 is equal to 7 minus 4, you see how all they did was switch the order. That's technically called the commutative property, but you don't have to know that for the test. So what you'll have to do is the homework will look something like this. It will say -4 plus 7 equals blank minus 4. And in the homework, you'll just say, oh yeah, it's my 7. It's the switch. They just did a switch. Okay, that's what the homework's going to be like. Let's go through another one that's a similar example. So like one would be parentheses. If you have 5 plus 4 plus 3 over 4 is the same thing as 5 plus 4 plus 3 over 4, and this in parentheses, right? So again, in the homework, if it was all you would be doing was, like I say, they move the 5 or move the 4, right? You can easily do that. So it's the same thing. Then you have adding 0. So if you have 3 plus 0 equals 3, right? So if they give you one that says blank plus 0 equals 7, you would automatically know, what do they want the answer to be? 7. 7 plus 0 is 7. Okay, so you're just basically going to be filling these in. Let's do some now with multiplication, right? If you have 4 times 6, it's the same thing as 6 times 4. Okay, you can write it either way. And then the same thing is true with the parentheses on that, right? If it was 4 times 6 times -2, it doesn't matter if you do this way or this way, right? Either way is fine. It's just switching the order. And then if you do anything times 0, so if you have 3 times 0, you get 0. So if they wrote something that said 4 times something equals 0, what would the answer be? 4 times 0 is 0, right? Okay, you guys have got it. I believe in your abilities. I'm not doubting that. And then lastly now, with distributive property, is if we had like this, 5 times 4 plus 3, right? That's the same thing as we do 5 times 4. So we had 5 times 4 plus 5 times 3. Okay, so if you have to write that, that's the distributive property. Okay, so that's an important one. So if they wrote something like this, 5 times 4 plus 3 equals, and then they had 5 times blank plus 5 times 3, you would know what's here, what's being multiplied, the 4. Yay, because that's going to be the distributive property. Okay. Now, using what we've recently covered in this lesson, we have the inverse property of addition. So if we have 4 plus a -4, that's going to equal 0, right? So if we have 4 plus what equals 0, we would say, oh, the answer would be -4. If anything like that, it's going to be pretty easy, okay? So I believe that you guys can do that. It really doesn't get any harder than that. This is our last lesson before our review, and then our last test, and then we are on summer break. Woo! So excited about that. Page 513 is our homework. This is 11.8. We are doing 1 through 20 all. That's it. Just 1 through 20 all. Really not a very hard lesson. You guys really should be able to knock this one out of the park. So that's all that I got for today. Enjoy the beginning of your week, and I'll see you all later. Mr. H is over and out.